Hello everyone, my name is Tanishan, and now I am going to talk about the introduction to quantum annealing and its theoretical foundations. So, quantum annealing is a computational method that is designed to solve optimization problems by finding the lowest energy state of a system. So, unlike classical methods that explore solutions sequentially, quantum annealing uses quantum effect to explore many possibilities simultaneously. So, it relies on three key principles of quantum mechanics that are superposition, entanglement, and quantum tunneling. So in superposition, electrons can exist in multiple states. So for quantum annealing, this means a quantum bit, a qubit, can represent both 0 and 1 simultaneously. This allows a quantum annealer to explore multiple solutions at the same time. So the next one is entanglement. Qubits in a quantum system can become entangled, meaning their states are interconnected even across distance. This property helps quantum annealer coordinates the search for optimal solutions across many variables. So the third one is quantum tunneling. Quantum tunneling allows the system to tunnel through the energy barrier rather than climbing over them. So this ability helps quantum annealing avoid getting stuck in suboptimal solutions. So now we are going to talk about the IC models. So the problems are encoded into the IC models, where variables like spin represent the solutions. The quantum annealer evolves the system to its lowest energy state and solving the optimization problem.
Now, let's explore the technical foundation behind quantum annealing, a specialized approach to solving complex optimization problems using quantum mechanics. Quantum annealing uses special tiny circuits called superconducting qubits. These can exist in two states at the same time, called superposition, thanks to a small component called a Josephson junction. Qubits are connected to each other so they can work together to find the best solution to a problem. Qubits are very sensitive to heat and interference, so the whole system is cooled to nearly absolute zero, about 15 millikelvin, using a dilution refrigerator. This keeps the qubit stable enough for the quantum process to work. Before solving a problem, it must be changed into a form that the quantum computer can understand. This is done using a method called quadratic constraint binary optimization, QBO, which turns the problem into simple yes or no choices for the qubits. The process starts with all qubits in a simple, low-energy state. Slowly, the system changes into a new state that represents the problem. If done carefully, the system will naturally settle into a best possible solution on its own. Special electronics control the whole process, managing the timing and connection between qubits. These controls must be very precise because even tiny errors can cause the wrong result.
Hello everyone, my name is Siti Naresha. I will be talking about the applications of quantum annealing in logistics. What is quantum annealing? Quantum annealing is an optimization process for finding the global minimum of a given objective functions over a given set of candidate solutions by a process using quantum fluctuations. Why logistics need optimization? This is because the logistics industry faces daily challenges like choosing the best delivery routes, balancing warehouse inventory, scheduling staff fairly, and managing shift arrivals at ports. So now let's go for the applications. First, warehouse optimization. Quantum annealing helps distribute stock between warehouses efficiently, avoiding overstocking and stockouts while lowering storage costs. Second, route optimization. Quantum systems help delivery companies find the fastest and most fuel-efficient routes, even when there are multiple destinations, traffic patterns, and time windows. Third, port scheduling. Quantum system helps schedule ship arrivals, container unloading, and dock usage to avoid congestions, delays, and high costs at busy ports. Now, let's go for one real-world example of quantum annealing in logistics comes from Volkswagen. They partner with D-Web to improve traffic flow in a large city. Using a quantum annealer, they analyzed data from over 10,000 taxis in Beijing. The system optimized routes in real time, reducing congestions and helping drivers reach their destination faster. This project showed that quantum annealing can handle complex logistics problems on a very large scale. The main outcomes of using quantum annealing in logistics include reduced city traffic congestions, lower fuel consumption, and shorter passenger waiting times. Together, this improvement makes transportation system faster, more efficient, and more sustainable.
Hello and welcome Dr. Chi. I'm Peter Sao, and today I will be explore how quantum annealing is being applied to solve complex problems in finance. First, risk parity and asset allocation. Quantum annealing helps balance portfolios so that each asset contributes equally to overall risk. By monitoring and balancing the covariance matrix, we can explore combinations of asset weights that satisfy risk parity while minimizing tracking error. Number 2, arbitrage detection. In arbitrage, the goal is to exploit price inefficiencies across assets or exchange. Quantum annealing enables us to encode threats, costs, and constraints into a graph or matrix, helping us discover trade sequences that maximize profit or minimize costs within defined limits. Number 3, fraud and anomaly detection. Identifying irregularities in large transaction dataset is vital for security. Quantum techniques can detect unusual grouping or outliers, improving performance in clustering or pattern matching models to enhance fraud detection. Number 4, derivative pricing. Pricing complex derivatives often require Monte Carlo simulations, which are computationally heavy. Quantum annealing helping by optimizing sampling path or adjusting parameters to accelerate convergence, leading to faster and more efficient simulation. Number 5, credit scoring and risk classification. Quantum annealing assists in categorizing clients based on credit worthiness using various indicators. It can also be used to find optimal rule sets or weighting under constraints to help minimize false positive and improve risk evaluation.
Hello everyone, my name is Ong. I'll be talking about how quantum annealing is being used in machine learning and where it is heading in the future. Quantum annealing helps solve tough optimization problems in machine learning. One key application is feature selection, where it helps choose the best inputs for a model, improving accuracy and saving time. It's also used in training restricted Boltzmann machines, where it can speed up how models learn patterns. And for tasks like clustering and pattern recognition, it gives better results in complex data. Looking ahead, the future is exciting. We'll see more hybrid quantum and classical systems combining the best of both worlds. As hardware improves, quantum annealers will scale to tackle real-world datasets directly, and new quantum-native algorithms will emerge, built specifically to run on quantum machines. So, quantum annealing isn't just theory. It's already changing how machine learning works, and there's much more to come.